Welcome to the Form 2 Science Lecture, Chapter 8, Section 2, Electric Current. In a previous lecture, we have learned about how to make electricity flow. So, what things are actually flowing in metals? What is an electric current? All matters is made up of atoms. Here is the model of an atom. For an atom, there is a nucleus in the middle, and some electrons moves around the nucleus. In some materials, for example metals, there are electrons which do not belong to the particular atom. These electrons are called free electrons. On the other hand, nonmetals have no free electrons. Consider a metal wire in a circuit here, which is not connected to a dry cell. In the metal wire, the free electrons moving randomly in all directions. Now we connected a dry cell in a closed circuit. The free electrons in the metal wire moving in the same direction. The free electrons in the wire flow from the negative pole of the dry cell to positive pole. The flow of these free electrons forms an electric current. Actually, we cannot observe the flow of electrons by naked eyes. So, a water pipe system may be used as an analogy to help us understand the concept of an electric current in a circuit. The water pump, which pumped water to flow, represents a dry cell. The water pipe represents the wire in a circuit. The moving water turbine pushed by the water, representing the bulb, lights up. The directions of the water flow is representing the directions of the free electron flow. Here is the summaries. Metals have a lot of free electrons. The flow of electrons in the same directions forms an electric current. Try to make some drawings on your notes to help you remember the key points in the summary more easily. Before electrons were discovered, an electric current was thought to be a flow of positive electric charge from positive pole to negative pole through the wires. That means the directions of free electron flow is completely opposite the directions of electric current. So now we know that the directions of electric current is wrong and do not exist. So why we still follow this? Prepare your answer and we will discuss during the lessons. Let's move on to next part, measuring electric current. To measure electric current, we can use ammeter. The unit of electric current is amperes. Its short form is A. Small electric currents are measured in milliamperes. We can write the short form of MA. We should always connect the red terminal of the ammeter towards the positive pole of the dry cell and the black terminal towards the negative pole. When the electric current in a circuit becomes larger, the brightness of the bulb increases. You can look at here, larger current in this case, so the brightness of the bulb increased. Here is the summary. An ammeter is used to measure the size of an electric current. The units of electric current are ampere, A, and milliampere, MA. This is the end of Chapter 8, Section 2. Hope you guys enjoy it. Try to make some drawings on your notes and review this chapter when you have time. Please work hard, and I hope to see you guys soon.